each of A1, A2, A3 is associated to unique B1, B2, B3. X, Y both are subsets of set of reals, and a function f here in the diagram. X1 is the preimage of Y1, X2 is the preimage of Y2, and X3 is preimage of Y3. Now we move to the next topic, that is called mapping or function. Actually, mapping or function is not new thing. Mapping or function is a special type of relation. Therefore, it is not quite new. First, I draw few diagrams or arrow diagrams. After that, I shall explain. I have drawn three figures. I call it figure 1. This is figure 2. And this is figure 3. And taken two non-null sets A and B. Taken three members of set A, A1, A2, A3, and four members of set B, B1, B2, B3, B4. Now in the first diagram, we see that each of A1, A2, A3 is associated to unique B1, B2, B3, and B4, which is member of B, is not associated to any member of set A. In the figure 2, we find that A1 is associated with B1, A2, A3 are associated to the same member B2, and B3, B4, two members of B are not associated with any member of set A. In third diagram or figure, we see A1 is associated to two members B1, B2. A2 is associated to B3, A3 is associated to B4. Now, function, a particular type of relation, is defined as a rule or a condition or a property, also called correspondence, which associates every member of set A to a unique member of set B. Now, again, I say a special type of relation, I express that, or we express that by f. Actually, that is function, initial letter of function, which associates every member of set A to a unique member of set B. In that case, we say that rule or condition or property or correspondence as a mapping. That means a mapping is a special type of relation. According to that condition, here f is a function. Also, in this case, f is a function. Here, A2, A3, these two members are associated with the same member B2. But in case of figure 3, we see A1 that is associated to two members of set B. As per definition, this is not a function. This is a function, no problem, according to the definition of function or mapping. Actually, we use the term function generally in case of calculus, and in case of algebra, we use the term mapping generally. Thus, a special function, and this is represented by the symbol not x. Later on I shall take x. In this case, A is domain of the function or mapping is set A, and range of A is subset of B, and B is also called codomain, as mentioned earlier in case of relation. And we write this also, this matter, if A1 equal to B1, if A2 is equal to B2, if A3 is equal to B3. But for this example, if A1 equal to B1, if A2 is equal to if A3 is equal to B. Thus, with the help of arrow diagram, I have given the idea of function. Note, this is not the case of function. Therefore, finally, the function is defined from a non-empty set A to non-empty set B is a rule or condition or a property or a correspondence such that every member of set A will be associated to or with a unique member of set B, and that is expressed by F, special type of relation from set A to set B. Domain of F will be A. This is very important in case of function. This is not ordinary relation, and range of F will be subset that may be proper or improper. Here it is proper, that is why I have used this symbol, and B is the codomain. Next, function defined on set of reals, defined on set of real function. Real, that is why we call real function. If the domain and range be subset of set of reals, in that case we say the function as a real function. Here we take two sets, X that is subset of set of reals, also Y that is also subset of set of reals, and the function F. Therefore, we denote that F X to Y. That means if I draw X set, Y set, and a function A, I take three members x1, x2, x3, y1, y2, y3, y4. X, Y both are subsets of set of reals, and a function F defined by this, and I take X are members of capital X and small y's are members of Y, and also express Y equal to Fx, and say that F is a function from set X to set Y given by Y equal to Fx. Now we are going to discuss different types of functions. number 1 into function, number 2 1 to 1, also 1 1 in short, injective function, onto function or surjective function. Let us now discuss one by one. First of all, into function. Actually, in this diagram, it is clear that x1, x2, x3 are each of these are is associated to y1, y2, y3 respectively. But we see here y4, a member of y, is not associated to any member of set X. That means y has one member that is not associated with any member of X. In such case, this function is called into function. That means what we find, if X, that is proper subset of set Y. One thing let me mention, X is called pre-image. X pre-image Y is called image. X is called pre-image, Y is image. Here in the diagram, x1 is the pre-image of y1, x2 is the pre-image of y2, and x3 is pre-image of y3. On the contrary, y1 is the image of x1, y2 is image of x2, and y3 is image of x3. And here we find fx, that is the range of the function f, is proper subset of y. In this case, we call f is into function. Thus, we can define if f is a function from set X, of course non-null, to set Y, and if X is proper subset of Y, then f is called into function. I can take an example. Say x equal to define y then a function f from x to y. This one is the problem. Now we see f1 will be equal to 3, f2 will be equal to 4, f3 is equal to 5, but 6 has no pre-image. Therefore, fx is proper subset of y. Therefore, f is into function. From x to y. Thus, I have discussed into function